Imagine an AI that teaches itself to think without any human supervision. No pre-programmed answers, no training wheels, just raw intelligence evolving on its own. Meet DeepSeek R1, the groundbreaking AI model that's redefining how machines reason, learn, and outperform expectations. Hey everyone, welcome back to the channel where we decode the most exciting tech breakthroughs. Stay tuned to discover one of the most significant breakthrough in the field of LLM, DeepSeek R1. Incentivizing reasoning capability in LLMs via reinforcement learning, DeepSeek R1 is a revolutionary AI model. Therefore, it pioneers a bold new approach to machine reasoning, using pure reinforcement learning without the need for traditional supervised fine-tuning. But unlike existing models that rely on pre-labeled data, DeepSeek R1 learns through trial, error, and self-improvement, mirroring human-like problem-solving development. While the two-stage evolution of DeepSeek R1 is phenomenal, certain issues remain to be resolved moving forward. Everything starts with DeepSeek R10, which is a first-of-its-kind model trained exclusively via reinforcement learning from scratch. It exhibits emergent reasoning behaviors, self-verification, reflection, and long chain-of-thought problem-solving. It achieved a 71% accuracy leap on AIME 2024, proving that AI can enhance its reasoning without human-labeled guidance. However, it suffered from poor readability and language inconsistency. It achieved a 71% accuracy leap on AIME 2024, proving that AI can enhance its reasoning without human-labeled guidance. However, it suffered from poor readability and language inconsistency. On the other hand, DeepSeek R1 improved upon R10 by integrating a multi-stage training pipeline. It introduced a small set of cold start data to refine coherence and human-aligned reasoning. Therefore, it achieved performance on par with OpenAI's O1-1217 model, rivaling industry leaders in AI reasoning. However, it might encounter some weird overthinking scenarios when facing everyday problems. Even with some potential drawbacks, here's some key innovations that DeepSeek brings out to the world. Instead of feeding it human-labeled data, DeepSeek R1 figures out solutions by optimizing its own strategies through reinforcement learning. The powerful reasoning capabilities of DeepSeek R1 were transferred into smaller, more efficient AI models, outperforming standard methods in scalability and performance. This method is called distillation. With a groundbreaking performance, especially on math and coding, with 97.3% on Math 500, DeepSeek outperforms major AI competitors. It achieved 96.3% human-equivalent ELO rating on CodeForces. It also outperformed existing models in factual Q&A, creative writing, and complex problem-solving. The aha moment, AI that teaches itself to think. One of the most astonishing discoveries during training was DeepSeek R10's spontaneous development of self-reflection. Midway through its reinforcement learning cycle, the AI started to reevaluate its own reasoning, correct mistakes, and optimize its answers, all on its own. This phenomenon signals a major leap toward autonomous AI cognition. Therefore, DeepSeek R1 is more than just an AI upgrade. It's proof that machines can teach themselves how to think. By eliminating reliance on human-curated data, it paves the way for truly self-improving AI systems. However, will we achieve such AI systems or even AGI with transformer-based models? Here comes another question. What is a transformer? Everything started with the concept of artificial neural networks, which inspired by the biological neurons in our brains. The starting point is feed-forward networks. They are great for processing fixed-size inputs to produce fixed-size outputs, but they are not great for processing a variable-sized sequence and producing variable-sized output. Therefore, it means that the model is totally incapable of chatting with you. The next milestone is recurrent neural networks. In recurrent neural networks, your input was analyzed over and over again when you give it a sequential data. This iterative mechanism helps this model to remember some context of historical user input. However, it is still far from being able to having basic conversation with you. But shortly after, long short-term memory networks appear to solve part of the issues with recurrent neural networks. In summary, they improve to remember more things from the past and the context, allowing them to perform better when dealing with time series data and sequential data. Therefore, even this is still not enough to have a talk with you. It is already good enough for making predictions based on historical data with their underlying trends. However, here comes the monumental milestone in AI field. Back in 2017, researchers introduced the transformer model. Even it's still based on neural network architecture. Instead of processing words one by one, transformers look at the entire sentence at once, using something called self-attention. Think of it like this. Instead of reading a book word by word, the transformer scans the whole page instantly, figuring out which words are most important. It does this with multi-head attention, allowing it to focus on multiple meanings at the same time, like how bank could mean a riverbank or a money bank, depending on the context. Therefore, it makes AI models like ChatGPT smarter, faster, and more human-like in conversations. We can see that the essential logic around transformers is that they scan the input, pick up on hidden patterns, and spit out the perfect output. That's exactly why they started off as language translators. Because let's be real, most languages follow similar patterns. Crazy, right? But here comes the huge problem. Is it possible for us to achieve AGI through any transformer-based models? Or in other words, is DeepSeek R1 the hope for us to achieve AGI with transformers? Or it reveals the practical ceiling of transformers and the need of creating a totally different base model? It is very plausible that if companies like OpenAI apply and scale up these reinforcement learning, RL, and distillation techniques, the practical performance of transformer-based models can be dramatically pushed upward. However, this upper limit is a moving target, influenced by both technical and fundamental constraints. Let's unpack this in detail. What really impresses us from DeepSeek is this combination of RL and distillation. They create a powerful synergy. RL lets the model self-evolve by exploring the solution space, and distillation efficiently transfers those learned behaviors to models that are easier and cheaper to run. But they are merely optimization methods based on the current model architecture. Therefore, if companies with extensive computational resources and large-scale data pipelines, such as OpenAI, were to adopt similar techniques at an even larger scale, that is the time for us to unlock the real power. The techniques used in DeepSeek have already shown that a model can learn to reason more deeply. Therefore, OpenAI has already been exploring chain of thought and similar ideas with the integration of large-scale RL and carefully designed distillation pipelines to accelerate performance gains. Admittedly, transformer-based models have demonstrated impressive scaling laws. There is empirical evidence that larger models with better training techniques continue to improve on benchmarks. RL and distillation add an extra dimension to this scaling. Rather than only increasing model size or dataset volume, they optimize how the model reasons and distills knowledge. This means that even within the confines of the transformer architecture, there is room for significant improvements in efficiency and capability. But let's not forget that one of the notable achievements in the DeepSeek work is obtaining competitive performance with lower computational cost. Therefore, if companies like OpenAI harness these methods at scale, they can potentially deliver models that are not only more capable, but also more energy efficient and faster to deploy. No one knows what would happen if there's a mass production of AI models. But despite these promising aspects, several considerations and limitations remain. Is there a ceiling of the transformer architecture? And how far away is it? Even if reinforcement learning and distillation allow us to approach the practical limits of transformer-based performance on current tasks, there may be diminishing returns. The upper limit of a transformer may be determined not just by training techniques, but also by the architecture's inherent capacity for representation and reasoning. Therefore, at some point, additional improvements might require architectural innovations or hybrid models that integrate, for example, symbolic reasoning or new forms of memory and attention. The paper rendered issues such as reward hacking, language mixing, and sensitivity to prompts. These challenges suggest that while reinforcement learning can drive significant improvements, it is not a silver bullet. Robust reward models and more stable training protocols will be necessary, especially when scaling up, where even minor instabilities can be amplified. Much of the performance gains discussed in DeepSeek are measured on specific benchmarks. Reaching the upper limit for these tasks is one thing. Achieving broad general intelligence or handling the full spectrum of human language understanding and generation might require breakthroughs beyond the transformer paradigm. Therefore, we may reach a plateau for certain kinds of reasoning tasks while still having open challenges in other domains. Scaling up these methods will also depend on the availability of high-quality, diverse training data and the computational infrastructure to support long-horizon reinforcement learning training. The cost and complexity of training very large models with reinforcement learning on a massive scale may introduce practical limits even before the theoretical upper limit of the transformer is reached. Therefore, given all these points, the following picture emerges. The impact on short to medium term. With more companies applying advanced reinforcement learning and distillation methods, we are likely to see a new generation of transformer-based models that dramatically outperform current systems on reasoning and specialized tasks. But these models could be seen as approaching a practical performance ceiling within the current paradigm. It means that we might soon extract nearly all the performance that can be squeezed out of the existing transformer architecture. The impact on long term. Surprisingly, against human intuition, the upper limit of transformer-based models is not an absolute boundary. As we better understand the interplay between architecture, training dynamics, and data, further innovations will be needed to push beyond what pure scaling and better training can achieve. Therefore, while reinforcement learning and distillation will bring us closer to the current ceiling, they may also illuminate where that ceiling is and what might be needed to break through it. However, these limits are bound by both technical constraints and fundamental aspects of the transformer model itself. In the near future, we can expect significant improvements along the lines of DeepSeek's methodology. Yet, the quest for truly general AI will likely require a broader array of innovations to redefine what the upper limit of AI capabilities truly is. Therefore, while transformer-based AI models have room to improve significantly through these methods, the journey to an absolute upper limit is ongoing, and each new breakthrough not only raises the ceiling but also reveals new horizons beyond it. What do you think? Could DeepSeek push the field of LLM to a bottleneck? Let me know in the comments below, and don't forget to like and subscribe for more insights into the tech shaping our world. Thanks for watching.